Variation, and it's all its myriad differences, I guess. I couldn't find the word. So variation. It's quite simply a function like y equals x is variation, and more specifically, direct variation. What do I mean by direct variation? Right now, the value of y is directly impacted by the value of x. And so it varies with respect to the value of x. That's just in general. Specifically with this particular function, as I laid out y equals x, as x goes up, y also goes up, because that function looks something like this. Okay? So as I increase in my x value, my y value increases, and that's direct variation. As compared to inverse variation, where I have two variables, let's say y equals 1 over x, and y equals 1 over x is, as I put in an x value, let's say 1, out comes a y value 1. So x is 1, y is 1. X is 0 is undefined, so I get this asymptote. And if I put a 2 in there, I get 1/2 for y. And if I put a 3 in there, I get 1/3 for y. And so I get this. Okay? This is where x, as x increases, goes that way, y decreases, goes down. So as I go across this way, my y value goes down. It decreases. That's inverse variation, because they're inversely related. X goes up, y does the opposite. It goes down in value. So that's inverse variation. And we can have various combinations of such, and oftentimes there's going to be a constant of variation. And so typically I will have formulas or equations out in the real world that exist and describe or predict what's going on between two different things. So what's a good one? As age increases, shoe size increases. Generally so. We can't predict because of genetic variations, but generally a baby's foot is smaller than that same baby's adult-sized foot as they get older. And at a certain point it plateaus. So the function might look something like this. Okay? And it may even go down if you think that your feet shrink. I don't know if that's the case. We certainly get shorter, but I don't know if our foot size shrinks. So, but generally, as x increases, y increases, even if it's a tiny bit here versus a lot right in here. So that is direct variation. But for me, the rate at which that goes, let's say that mine is the yellow version, but somebody like Shaq, his maybe grew faster and grew larger, and so the constant in front of his, let's say that shoe size equals age, there's some constant that works with mine, and so I get a equals, I have no idea, 1/3 a, but his goes up faster, so maybe his is 1/2 a or something. I don't know. I'm just making that up. Maybe it's 3 and 2 or 2.73, whatever. It doesn't matter. And you wouldn't get this function because that would have to be a cubic of some sort, or a fifth or a seventh or whatever. But what I'm saying is this constant will change and dictate what happens differently between, for instance, my shoe size as my age increases versus Shaq's shoe size. That would be Shaquille O'Neal for you young people. Look up his shoe size if you wanted to. Versus my normal, maybe even a little bit slightly less than normal shoe size. Okay? But variation can come in different forms. So for instance, you definitely know that the volume of let's say the volume of a cone is equal to the height of that cone divided by the area of the base, which is a circular base. Hopefully you remember this from geometry, which is pi r squared, and all of that divided by 3. So that means that the volume of the cone is varies directly with the height of the cone, h, with the radius squared, or r squared, of the cone. Okay? You can also have things inversely related at the same time. I can't think of anything practical, but let's say, I'm sure there's something from engineering from my previous life, but that's 30 years ago. But let's say that B, whatever it is, varies directly with A and inversely with C squared. So to build that, I would have B equals some constant K, which I don't know, times A, because it directly with A, but inversely with C squared. So oftentimes I'm going to give you some situation that B is equal to 7 when A is equal to 5 and C is equal to 2. If I know that that's the case, I can use that information to figure out what this K value is, or the constant of variation. I'm going to put 7 in for B, leave K as K, put 5 in for A, and put 2 in for C, and I'll get 7 equals 5K over 4. To figure out what K is, I'm going to have to multiply by the multiplicative inverse, 4/5, multiply this side by 4/5. Or if you prefer, multiply by 4 and then divide by 5. But I'm going to get 7 times 4 is 28/5 is equal to, those all equal 1, so I get K. So my final formula for whatever this is, something that I made up, it's 28/5 times A over C squared. And then oftentimes I'm going to give you another A and another C and ask you what B is. Okay? So that's direct variation and multivariable variation with some examples.